Hello, everyone, and welcome. Thank you all for joining us for today's session. My name is Firas, and I'm the event planner for Microsoft Reactor in Redmond. Before we start, there are a few things that I'd like to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful for your commentary and please remain professional and on topic. This session is recorded. It will be available through the Microsoft Reactor YouTube channel in 24 to 48 hours. I'll be sharing the link for our YouTube channel in the chat. I'll also be sharing some links for our survey and the link for our Meetup page. Which brings us to our session today. Our session will go for approximately an hour with time for questions within. Our speaker for today is Jim Bennett. He's a regional cloud advocate. I'll now pass this along for you, Jim.
Awesome. Thank you very much. Hello, everyone. Good morning, good afternoon, good evening. Welcome wherever you are in the world. Welcome to lesson 4 of IoT for beginners. So just first of all say hello to some old friends who've been joining us. So Kamal, hello, glad to have you back. Yeah, welcome. Thank you for joining us. Samuel, very, very keen. 4 minutes before we started, there was a comment saying, waiting, it's buffering. So glad to have you here. Welcome. Thank you for joining us from Angola, of all places. Thank you very much. It's great to have such a wide audience from all around the world. Hi to Svo08. Great to have you here. Thank you. And Gert, hello again. Welcome back. Glad to see some names from some of the last episodes. Glad to have you here. And Matt Hutt from Sweden. Thank you for joining us. And Javier as well. Hello. Great to have you all with us. And Shatu Good Tech, another name I recognize from these episodes. Welcome. Glad to have you here with us today. So for those who are new to these streams, I'm Jim Bennett. I'm a cloud advocate from Microsoft, absolute IoT nut, live streamer, and just generally somebody who's here to kind of share the goodness of tech with the world. And yes, I'm very happy today because I'm about to go on vacation for a week. So be nice and happy and bouncy all today. I'm all over the internet at Jim Bob Bennett on Twitter, GitHub, Instagram, LinkedIn. Please feel free to connect. If you've got any questions about what we talk about today, just reach out and I'm more than happy to answer your questions. If you want to geek out on IoT, show me the cool things you've built, please get in touch and share with me. I love just geeking out on tech. Isaias, another face from Angola. Great to have you here. This is awesome. Welcome. Denz Al says hello. Great to have you here. And Jerry Warzone, hey, hi, I'm new here. Glad to have you here. For those folks who are new, actually, this is episode 4 of 3 episodes. Sorry, 3 episodes? Episodes 4 of 4 episodes. So if you're new here, you may have missed the previous 3. But we do have these all available on the Microsoft Reactor YouTube channel. So I'll just get a link to that dropped into the chat. So if you want to head to the Microsoft Reactor YouTube channel, you'll be able to find all the previous episodes of this series if you want to catch up. Now, the reason we're running this series is because July is one of the best months of the year, because July is July-OT. Yes, July-OT, a whole month where the whole world should be dedicated to the Internet of Things just because of the beauty of July-OT. It's just, the name is just fantastic. And so July-OT is a month where we at Microsoft, we share a whole lot of really cool Internet of Things content. We encourage the developer communities to join in and share whatever they're working on as well. So if you head to julyot.dev, just have the link dropped to the chat. Thank you very much for that. If you head there, you will come to our July-OT page, our homepage for July-OT. From here, you can join our Cloud Skills Challenge, where you can compete with other people to upskill in Microsoft Cloud technologies around the Internet of Things. So far, we've had hundreds of people completing thousands of Microsoft Learn modules. So join in and compete with people to upskill in IoT. We've got digital swag. You want to get this little animation for your social media, or you want a cool desktop background like this one. We have all that available on a digital swag. You just download this, Teams backgrounds, desktops, whatever, it's all here. We've got a load of live streams throughout July. I know we're the 22nd of July already, but we've got loads more coming up. So you can catch up on the previous episodes here as well. Plus, we've got loads more coming up, including some episodes of Julio-T, which is July-T in Spanish. So my friend and colleague Bruno is running 3 episodes around Azure AI IoT with the Raspberry Pi and the reterminal, and he's going to be running those in Spanish as well. So you want some Spanish Julio-T, it's all there for you. And then we have a July-T blog. And this pretty much every weekday we publish 1 or more pieces of IoT content, whether it's directing you to a live stream, giving you information on .NET Nano framework, helping you to get certified, teaching about autonomous systems, Spanish post all about controlling water rockets with Arduino. It's all here. So if you head to julyt.dev, head to the blog, there's a whole lot of great content on here. And we're going to be updating this every day throughout the rest of July. So, okay, we have a question from Jerry Warzone, and a big question. So what does Jerry say? I need help with something and no one is willing to help me. Okay, so this looks like a good question. So I'm an international student here in the USA. Welcome. As you can tell by my accent, I'm international. I'm not American. I am British. Now I live in the UK. Doing an IT management master's and a 22. Oh, nice. Did an undergrad in chemistry and transfer myself to IT. Now that is pretty cool. I actually have a master's of chemistry degree. So my background is in chemistry. I actually have a master's degree in chemistry. So that's pretty cool. And I'm learning JavaScript by myself. So I need help with, I don't have any experience with coding or anything, but I started JavaScript directly by my own to learn it. Do you think to start JavaScript? Before that, should I learn any other basic language? Okay, this is a really good question. And this is a question we do get a lot from students or folks looking to get into tech. Not quite related to IoT, but that's cool. Yeah, happy to take a minute to talk about this. Do you think start with JavaScript? Yes and no. So the 2 most popular languages are JavaScript and Python. Those are the 2 that you really want to learn: JavaScript and Python. If you want to increase your chances of getting access to the widest range of jobs. Python, great for IoT if you're doing it on small board computers like Raspberry Pis. JavaScript, obviously, you can do a lot of stuff with that. It's worth looking at things like boot camps. There's a lot of great boot camps out there where we can get upskilled in 3 months. Just be a little bit wary. There's also some boot camps that are not so good and are there to suck money out of you. So, do your research for boot camps. But if not, we have a whole lot of great content to get you up to speed. In fact, I will just grab a link and I'll share this with you. /web dev beginners. Double check that's the right link. Yes, let me drop this link in this chat for you. Yeah, this is Web Dev for Beginners. This is 24 lessons to get you up to speed in JavaScript, HTML, and CSS. So this is a good place to start for you to kind of work through if you want to get upskilled in HTML and CSS. But keep an eye out for any more React videos. It's a little bit off topic, so I'm not going to spend any more time talking about this. But we have a lot of great React career sessions, discussions, but also feel free to reach out on LinkedIn and we can have this conversation there. But anyone else who's watching, if you want to chime in and help Jerry, please do. Marco says hi from Mexico, from Juanito. Welcome. Glad to have you here. So Jerry Warzone continues with, my main question is, if I don't have any job experience and apply for a job on the company, I prove them if they, yes, I have the skills to work with JavaScript. So will they hire me with that experience? That is a great question. So one advantage of boot camps is they will help you get through the kind of hiring process into a job. It's also worth building up your portfolio. So you may not have any commercial experience, but do you have a GitHub repo with projects that you've worked on? Do you have websites you've built or other JavaScript code that you can demonstrate? So if you can't demonstrate on the job experience, think about your portfolio. So, good questions though. Samuel's getting back on the IoT topic and says, how can I apply for IoT career in Microsoft? That is a great question. First place to go for is careers.microsoft.com. This is where all of our jobs are listed. Head on there, And if you search for, say, IoT, 188 results we've got around IoT. So there's kind of loads of great things that you can do in that space. If we go for country region, you're in Angola. I don't know how much we're hiring in Angola. Certainly across Africa, we do have we have a number of Africa developer centers, one in Nigeria and one in Kenya. So we've got a lot of growth happening in Africa. So yeah, careers.microsoft.com is a good place to start. Build up your IoT portfolio. Kind of same advice for Jerry. Build up your portfolio, got things you can show off, and then apply. One thing that is cool is Microsoft does a lot of remote hiring. So for a lot of roles, you can be remote. So it doesn't matter where in the world you are, you can still be hired and be part of Microsoft. So yeah, head to careers.microsoft.com, search for IoT, see what you can find out from there. Jerry's back with, should I learn Python before JavaScript? That depends. It kind of depends on what you want to do with your career. You want to build websites? JavaScript. You want to do data science, build cloud infrastructure? Python. It's a good idea to have a wide range of skills. The kind of more skills you have, the better. Let me just grab you another quick link from here. Where's the one I'm looking for? Oh, that's more Python for beginners. I don't want more Python for beginners. I want Python for beginners playlist. Let's see if we can find it. We have a whole Python for beginners set of videos on Microsoft Developer. Now, let me just give you the link to Microsoft Developer. Microsoft Developer, we have a load of videos on there. We've got Python for beginners, more Python for beginners, even more Python for beginners. Teaches Python. We've got Node.js for beginners as well. It's a lot of great video content on there to get you up to speed. Also, for the IoT people in the room, let me just let me just grab you an IoT video. I'm just gonna grab this one because I can. There's a new series we've launched. Where are we? New series we've launched on YouTube all around IoT. I'm going to drop this link in the chat here. New series we launched where I interview people about some cool projects, and some of them are IoT. And so we've got an IoT Altair 8800 in the first video. Check that one out. That's cool. Cool. Okay. So 12 minutes in, some great discussion. Haven't quite dived into IoT yet. So let's actually dive into IoT. And what we're working through today is the 4th lesson of IoT for beginners. And this is available at aka.ms/IoT-beginners. If you go to that link, it takes you to this curriculum, 24 lesson free open source curriculum. Teach you all about the Internet of Things. We do 4 lessons kind of getting started, and that's what we're working through as part of this series. We then do lessons from take on the journey of food from farm to table. So we look at farming, digital agriculture, soil moisture monitoring, feedback systems to automated watering systems. We then look at logistics, getting your foods to distribution plants or factories. We look at kind of capturing location data and visualizing that and geofencing. We do AI on the edge for manufacturing, and then retail. And then we do consumer IoT, where we look at building a smart timer. So if you ever said, Alexa, set a 3-minute timer, we teach you how to build that. So it's all here, all free, completely open source. So if you want to use this in the classroom, you want to use this to learn yourself, you want to take this for internal training at work, you can just take it, rip it apart, do whatever you like with it. It's all here, all free and available for you to use. Okay, another question from Jerry. So is this free code camp worth to get a certificate course, or can I stick up a Microsoft official certification course? I'm confused as to start very first from basics of blocks. What's the best place to learn? So all great questions, Jerry, but a little bit off topic for IoT that we're covering today. Please, as I said, I'm all over the internet, Jim Bob Bennett. Reach out to me on Twitter, Instagram, GitHub, LinkedIn, kind of whatever's your preferred platform, and we can dive into this in some depth. But also check out we have some reactor sessions for early and career folks that'll be really helpful for you as well. But yeah, please get in touch. So, yeah, don't want to dive into this too deep because this is an IoT session, but yeah, please get in touch, and I can kind of help you with that. So let's dive into lesson 4. So lesson 4 is all about connecting our devices to the internet. If you were here for the last lesson, we worked on sensors and actuators. So we got a Pi here. We've got a sensor, which is this light sensor here, and an actuator, which is my LED here. So if I cover my light sensor, the light comes on, the light goes off. So that's the feedback loop we built. And we built this, we connected to the Raspberry Pi using Visual Studio Code, and then just simple logic, read from the light sensor, depending on the value, set the LED on or off. And that's what we built last time. So today we're going to go a little bit further and try and connect this to the internet. We're going to think about how we connect IoT devices. Gabriel Alexander says, greetings. Is there any way to review July IoT's previous videos? Yes. If you have a look earlier in the chat, we have links to the Microsoft Reactor YouTube channel, and we've got all the previous videos in there. In fact, we just have the link dropped in the chat as well. Thank you for that. So you can check that out to get the earlier lessons that are all there. Jerry says, sounds good. Thanks so much. Yep. The focus on stage vehicles. Awesome. No, definitely please reach out. More than happy to help. Don't be offended if I don't respond straight away. I'm going on vacation next week. So my mind will be in a swimming pool. But yeah, if you reach out today, I'll try and have a chat today. If not, next week I'm on vacation. But after that, more than happy to help out. So today, connection to the cloud, we're going to look at sending and receiving messages, look at Mqtt, and kind of think about that connectivity part. So when we think about connecting to the cloud, the standard kind of way that IoT devices would work is you have your device, the thing, and then that would make a connection, usually over the internet, the I part of IoT, to some form of IoT service. So typically your one device would connect to one IoT service, and it would send data to that service. So that single connection, there'll be usually a secure connection between the device and the cloud, and they have data going back and forth to that one central point. And that kind of ingress point is your entry point to the whole world of your IoT application. So this is where you can connect to, data analytics using AI, or reporting, or mobile data, mobile access points, so I can get data from my IoT device from my phone, business logic, all that kind of stuff. So you have one ingress point through some kind of single cloud service, and that connects the rest of your IoT app infrastructure. And this is where data goes to the cloud from the device or back again. So normally when we send data from the device, we call it telemetry. That is kind of the first data. That's data we'd send when we're reading data from sensors, or we receive data from the cloud using the form of commands that tell the device to do something. And a lot of time, this connection between the device and the cloud uses some kind of standard communication protocol. And so there's a set of standards for how your device connects to the cloud. So what we're going to do today, we're actually going to look at some of these communication protocols. We'll talk about Mqtt, which is kind of one of the most popular for beginners, and probably easiest to understand example. And then we're going to look at sending telemetry for our light data, and we're going to look at sending commands. So what we're going to do, we're going to take this logic that we've built here to turn the light on and off and move that to the cloud. We're just going to run it locally. We're not going to deploy any cloud services. We're going to run it locally just to illustrate the point, but we're going to kind of take that logic to the cloud, as it were, so off the device. And Rick VD Bosch, that's a wave. Yeah, trying to lean in, because it comes up very, very small, that emoji. It's a wave. Welcome. Glad to have you here. Cool. So that's what we're going to do today. We're going to look at Mqtt. So let's talk about communication protocols. Okay. So the most popular IoT paradigm is kind of a pub-sub type idea, a publish-subscribe type mechanism. So the idea is you have multiple components that can publish to a broker, a thing that sits there and listens, and then you can subscribe to things off the broker. So you think of it like a big fat pipe, and you can push messages on and you can pull messages off. And then the way it works is when you push a message, you have some form of indicator what that message is. And then when you subscribe, you say what kind of messages you are interested in. So the kind of example would be you'd have multiple IoT devices publishing telemetry to the broker, and then you'd have your cloud service pulling telemetry off the broker. And it would just say, give me all the telemetry from every single device. And then if the cloud wants to talk back to a specific device, it would publish a message designed to go to a specific device. And then that device will be listening just for its own messages. So you may have messages that all devices listen to, or messages that one device listens to. So device A says, here's my telemetry. Device B says, here's my telemetry. The cloud says, give me all telemetry, gets it from A and B. Then the cloud might say, device B, here's a message, and only device B would subscribe to that message. And the broker sits in the middle and makes this happen. Great question from Siwa55. What's the best internet resource book I can take and do some projects with my Raspberry Pi? Great question. First one I recommend would be IoT for Beginners. We use Raspberry Pi in here. This covers a whole range of different topics. A lot of good stuff you can do with your Pi. If not, I would also check out Adafruit learning system. It's a super duper cool. And this has got a whole lot of projects in here that you can do with a wide range of different bits of hardware, including Raspberry Pi. So that's kind of the good one to find some projects, and then you can just try, I'll just drop that in the chat. You can just try some of those out, or Hackster. Oh. Hackster is sort of a hackers community. A load of cool projects on here. Again, using Raspberry, some use Raspberry Pi. Also, make sure you follow Raspberry Pi themselves on social media. They keep tweeting out a whole lot of these different things. Check out the Raspberry Pi blog as well. You often get good projects on there. Raspberry Pi often tweet out some good stuff. Great question. Great question. And yeah, obviously this is a live stream, it's a conversation. So anyone got any questions, feel free, just dive in and ask. So Mqtt is kind of one of the most popular communication protocols. Was originally designed in 1999, so it's 23 years old, which is practically ancient in technology terms, designed to monitor oil pipelines. So you use it for sending messages around oil pipelines. And it's actually released as an open standard by IBM in 2014, I think it was. So it's kind of an open standard that you can use to send messages around. And the idea is you have a single broker that you use, one broker, and then you can publish the broker and you can pull data off the broker. So rather than go one-to-one messaging, you put things on the broker, it comes off. So it kind of follows that broker, that publish subscribe type pattern. And everything that you send is given a named topic. So that's how you kind of get this idea of being able to listen to just things you're interested in. You have the idea of named topics. So you can publish to say, for example, /telemetry. And then anything goes to /telemetry, the cloud can then subscribe to /telemetry and pull all the messages off. But then you might have a topic such as /devices/1, devices/2, devices/3, and that'll be individual topics for individual devices. So each device would almost like create its own topic to get messages back. And the cloud could then target a particular device by sending a message to that one device based off the topic name. So all these are kind of named topics to send data, kind of named pipes to get data around. Question from Kamal. Yep. Is Mqtt a secured protocol? Yes. We won't be doing it securely today, but yes, it is a secure protocol. It does support usernames and passwords or certificates for sending data. So yes, it can be very secure. You can also sit it on top of other infrastructure, which is highly secure. So Azure Iot Hub can support Mqtt in a very secure fashion. You've got to use certificates or SAS codes to kind of sign in and connect. So yes, Mqtt is secure. Javier Mendel says, are we going to cover IoT Central at some point in the course? No, not IoT Central. This is the last lesson I'm running live. And if you actually go into IoT for Beginners, we do go into IoT Hub for everything because it's kind of trying to teach the basic principles. IoT Central is a Microsoft software as a service platform that sits on top of a wide range of different services. Means it's kind of really quick to get to spin up like an IoT application and get rules and dashboards and all that great stuff, but it kind of hides a lot of the complexity. With IoT for beginners, I want to teach the principles, which is why I start with Mqtt here, and then we go into IoT Hub because it's trying to teach the principles of an IoT service. So not IoT Central, but there's a lot of great IoT Central videos being put out by the IoT teams. So if you just go onto YouTube and search for IoT Central, there's a lot of great videos that teach you through how that works, which is pretty cool. Ravi asks, does Mqtt support IPv6? I don't know. I just connect based off a URL, and I don't know. I guess so. Qtt IPv6. That's a good question. Not okay. IoT Hub doesn't support it. Well, let's see whether Wikipedia mentions. That's just a useless match for us on the side. I don't know. Probably. Yeah, I don't know. That's one to dig into. Does it include encrypted like SSL? Yes, Mqtt can use SSL. Yes, that's what SSL endpoints. Okay, so let's actually connect to an Mqtt broker. So let's kind of just show a little bit of code to connect to an Mqtt broker. This is the eventual goal of what we're gonna build. So we're gonna have a nightlight. It's gonna read data from the sensor, send that data over Mqtt to our IoT app, which is just gonna be running locally for now. And that will then, if the meter and the light on, that will send a message back over Mqtt to the device that we detect by the device to control the LED. Okay, and then what we're gonna, oh, hello. Sorry, not sure what happened there. And then what we're gonna do is we're actually gonna use a free public Mqtt broker just to kind of illustrate the point. Okay, now going back to Kamal's question, is it a secure protocol? Yes, it is, but we are not going to be doing anything with security right now because security is a whole world of learning. We cover it in an IoT for beginners lesson, but there's a lot to it. So we're going to connect to test.mosquito.org. And this is a free Mqtt server that anyone can use. Okay, now because anyone can use it, you can use this for testing. Do not use this for any kind of secret data. This is just for testing, just using it to illustrate the point. And then when we connect to Mqtt, there's a number of ports you can connect to. Okay, so 1883 is an unencrypted, unauthenticated port. That's the default Mqtt port, and there's no encryption, no authentication. So that's, there's nothing, there's no secrets, no protection there. But then we can connect over unencrypted, authenticated, or encrypted, unauthenticated, authenticated, whatever type setups. And so if I connect over 8883, going back to Shotoku text question, this is essentially SSL. So this is connecting over SSL. If I want to do authenticated, I can either do authenticated not over SSL or authenticated over SSL. And that's authenticated with a username and password, or I can use a certificate. Use a certificate for it. Now, under the hood, Mqtt uses TCP/IP. So it just zips packets around the internet the same as you do when making web requests, but it sits on different ports. So you can't, if you have a firewall blocking things that aren't HTTP traffic, then you can't connect. But you can run Mqtt over WebSockets, which allows you to connect over HTTP and HTTPS. So if you have firewalls blocking, you can still use Mqtt over WebSockets. It's not as great because there's kind of a bit more underlying stuff happening, so it uses more power, but you can do it over WebSockets if you want to. So CUR55 says, so with this, I'll be able to create some kind of control panel API which can turn on off LED lights via the API. Yes, you can. So you have an IoT device that listens for messages, and then depending on the messages it receives, it can turn the light on or off. And then you just need something to send those messages to control it. For example, I have some buttons under my desk here, And you'll notice, I don't know if you can see, I've got lights behind me. And if I press some buttons, give it a second, always a bit slow the first time. There we go. You see it's gone purple. We've got some multi-colors, a few different colors. Got lights. I can press that button, you'll see it goes off. All the lights go off. Press a button, it goes on. Yeah, this is all using that. So I've got a little Raspberry Pi under there that controls all these lights. I send a message. I'm using Azure Iot Hub for it, but I send a message to that and it turns the lights on and off. So yes, totally can do that. This is all going through the internet. What I'm doing here is going through the internet. So it goes from I press a button under my desk, sends a message via my laptop to Azure Iot Hub in the cloud, which comes back down to control all the lights. So yeah, I can run it locally if I wanted to, but I do it over the cloud because it's a great demo. So yeah, see what it says nice. Yes, it is very nice. It is very nice. I like it. Yeah, you're welcome. So yeah, so we're going to use this test Mqtt org. Now, there's no guarantee this could be up. Occasionally it goes down. This is literally run as a kind of a volunteer thing, and it's not very powerful. So don't flood this with data. But some people do put interesting data on there that you can pull off for if you're interested. If you use this a lot, please sponsor or donate to this project as well. So this is what we're going to connect to, and we're going to kind of build the setup where we connect and send data. So what I'm going to do, just going to grab some code. The first thing we need to install on my Pi is a pip Python package to give me access to Mqtt. So Parho Mqtt comes from the Eclipse Foundation. That's kind of one of the easiest to get started with. So install that package. Already got it. I then just import the library into my Python code. And then I set up some connection details. Now, whenever you connect to Mqtt, you need to name your device. Because this is a public Mqtt server, there could be millions of different things on here. So when you connect this, it's good to have very unique names for everything. So I always put a kind of a GUID or similar prefix in my kind of client name. So I'm just going to copy a GUID so I know mine's unique, because I don't want to end up pulling other people's data off and confusing my nightlight. Yeah, if you were to be coding along with me right now doing this, I don't want to pull your data off and have you control my nightlight. So because it's a public Mqtt server, I need this uniqueness in there. If you're using your own private one, you wouldn't need this. So then I can actually connect. Someone's got this. Connect with my name. So when you connect, you have to have a name. I'm just connected to test.mqtt.org. This defaults to the 1883, the port 1883, unencrypted, unauthenticated. Obviously, I could encrypt if I wanted to. So that gets me connected. And if I just run my code here, you'll see Mqtt connected. So I'm now connected. So I've made this connection. I'm not doing anything. I'm just connected. So we call connect to actually make the connection. And then this loop start, this starts a background process that kind of sits there waiting for messages coming back. So rather than have my code continuously poll, I can start this loop that sits in the background, just kind of waiting to respond when I get a message to the broker. So I'm now connected. That's kind of the first step. I'm now connected. So now that I'm connected, what we'll do is we'll just kind of dig a bit more into Mqtt. And then we'll start looking at sending telemetry. So, as I said earlier, when you send stuff to the broker, you do it on named pipes. Sorry, named topics. Sorry, named topics. And so you can say, I want to send to like / telemetry. Now, these topics, we have / telemetry / temperature if you want. You can think of these like a directory structure. You can have like a top level topic, and then you can have subtopics. It's kind of got this hierarchy. And so if I wanted to send different types of telemetry, I could send on different topics. And that way I have different services listening for different telemetry. So for example, if I wanted to control some lights, like CWare55 wants to do, I could have a /lights topic. And then I could have /lights / outdoor /lights / bedroom /lights / kitchen. And then send messages back and forth from those. And so I kind of just work out which lights are receiving those messages. So you can kind of build up this quite deep hierarchies of topics if you want them. And so when you publish, you give the actual topic you want to publish to. I want to publish to /telemetry/humidity. But when you subscribe, you can subscribe to a specific topic. You can say, I only want telemetry/humidity, or you can do a wildcard. And you can say, I want to subscribe to everything in telemetry and get all the messages. It's kind of up to you how you want to subscribe to that. So it kind of gives you a lot more granular control of the data you get back and forward from the MQTT broker. Now, when you send these messages, although it's called MQTT, which stands for Message Queuing Telemetry Transport, it's not actually a message queue. Okay, if you've ever done any kind of queuing, the idea of a queue is you put things on and they stay on the queue until you take them off. And so it's got this long queue, things go on, you take them off. Now, MQTT isn't actually a queue. If there's nobody there to pull off the message gets lost. It's kind of one really important thing about MQTT. The message gets lost. So you actually have to, and you can actually configure what things you can do to kind of mitigate that thing. Okay. So the first thing you do with MQTT is you can actually have it keep the last message. So if you send stuff, the last message will always be available. So it doesn't matter if there's no one listening. When something starts listening again, it'll always be able to pull back the last message, just the last message, which in some cases is fine. If you're sending temperature data and all you care about is the current temperature, if your server is down, when it comes back up again, if it needs the current temperature to make a decision, that's what it cares about. So sometimes that's fine. If you need more messages to be stored, maybe MQTT is not the right protocol to use. It's also got what's called quality of service, which is around delivery guarantees. So you can do like fire and forget, which is I send a message and I don't care what happens to it. Or you can say, I will keep sending it until I get acknowledgement that someone's pulled the message off. Or I want to actually assure that it did get delivered. So someone actually did something with this message. So you need to kind of set the quality of service depending on what you want. Or very much it depends on what use case are, but kind of stuff to keep in mind. So yeah, I think this, I love this little picture, shows it great. If it's connected, the messages get received. If they're not, they just fall off. And yeah, you can set the retain flag to kind of keep the message alive. Now, there's also this idea of keep alive. So just keep holding. If you're connected to the MQTT broker, there's kind of an idea of keep alive. It's like a heartbeat, just kind of keeps going just to keep you connected, to stop the connection being dropped. Because MQTT, if you don't do anything with a certain period of time, it will drop you off. So you kind of need to keep alive to kind of keep that connection going. So what is telemetry? I keep mentioning telemetry. I've said telemetry is kind of the data you send from sensors. But telemetry is actually is a Greek word. It means to measure remotely. And actually the very first telemetry capture that I've seen, well, not actually seen because it was way before my time, was in 1874. That's the first one I read about. And so in Paris, they wanted to monitor the snow conditions in Mont Blanc for skiing. And so they actually had literally a long wire going from Mont Blanc to Paris just to send information about the snow levels. So it's the very first telemetry back in 1874 to monitor skiing in Mont Blanc, which I think is fascinating. We've been doing this kind of remote monitoring for such a long time. But what we mean in the IoT world is where we gather data from the sensors and send it to the cloud for processing. So back in lesson 1, we talked about a smart thermostat. We talked about this idea of we gather sensor data from temperature sensors all around the house. We send that to the cloud and use other data such as calendar, weather data to make thermostat settings to make decisions about how we control our heating, cooling type systems. The telemetry is the temperature data. So you might have multiple sensors that gather sensor data, gather temperature data in different rooms, and they send that via IoT device to the cloud, and that's the telemetry. And kind of how that gets packaged up and how you send that of MQTT kind of varies depending upon your needs. So you might send some temperature you might send telemetry labeled as thermostat temperature And then living room temperature and bedroom temperature as different telemetry packets. You might have one telemetry packet with multiple values in there for what's the thermostat, living room, bedroom. You might publish it to different topics if you want to analyze data in different ways. It's kind of up to you how you send that telemetry. It's kind of one of the contracts between the device developer and the cloud developer. If you have different people, different teams, that contract around how you send the telemetry is very, very important. You need to make sure the structure of the telemetry that you send matches what is being expected on the other side. CY55 asks a great question. What's the best practice for updating the software on these devices and also patching? Let's say if I put it somewhere in my garden or something like that. Great question. So if you, Mqtt doesn't support this, but a lot of IoT services do support this out of the box. So like Azure Iot Hub, for example, which is kind of an IoT service from Microsoft, does a lot more than Mqtt. That actually supports device updates. So that can push new firmware to your device. So you code up your device to be able to listen for new firmware, and it will download a new binary of the firmware and then reboot the device and redeploy that. So it's there is a whole lot of infrastructure for deploying new firmware to your device. So you need to make sure you tap into that. You could do it over MQTT by sending a command. So the device subscribes to a message to say update. The cloud sends a message to the device to say update. The device will then connects, maybe does a HTTP connection to a web server to download a new binary to update. But probably the easiest way is to look at things like Azure Iot Hub and how that does device updates, because that can handle all your firmware updates for you. It's kind of a complicated process because you've got to download the firmware to potentially a flash storage. Got to make sure you've got enough flash storage for new firmware, and then have a boot process that copies the new binary, the new firmware on top of the old firmware. So there are some complexities to it. If I'm just doing it at home, the great thing about using Raspberry Pi is I can literally remote connect. I'm remote connected to my Raspberry Pi on my desk. I can also remote log into the Raspberry Pi that's powering my lights here and literally just update the code myself. So if you're doing it yourself with Raspberry Pis, don't worry about flashing firmware. Just log in remotely and update it. CY55 says, do these things also work when you have an unstable internet connection? What happens if it starts updating a thunderstorm and my Wi-Fi drops in the middle of an update? So you have to manage downloading of the updates. So what you would do for that is step one would be I download the new firmware to flash storage. Then once the firmware is completely downloaded, you then kick off a reboot, and that reboot would copy the firmware over. So it would be two separate steps because internet is not reliable. So step one, download the new firmware. Step two, copy that over. You'd never do a direct from cloud to overwrite the firmware because the firmware needs to be running to download the code. So step one, download it. Only when it's downloaded would you then apply it. And that's on you to handle. So you need to make sure, a lot of the things like IoT Hub will handle all that for you. So you don't have to worry about that. It'll handle all that for you. Docker containers. Azure use things like edge computing. IoT Edge allows you to download Docker containers. That's pretty good for that. Camel says Azure Sphere can be useful for FOT, firmware over the air. So if you want to update, Azure Sphere can manage all that for you. That's a secure IoT platform. Arvin says, hi Jim, how are you? I'm great. I'm going on vacation next week. Very excited. Cool. Okay. Talk a bit about telemetry. Let's actually send the telemetry. Let's do this now. Let's actually send the telemetry from our device. And so what I need to do, I need to define my topic. So I've got my client name. I'm also going to define my topic. Again, I'm using my ID, so this is unique on the public test Mosquito.org server. So I've got my telemetry. That's where I publish to. And then what I'm going to do is I'm just going to update my loop here. Get rid of my LED logic. And what I'm going to do is I'm just going to send the telemetry to MQTT. So if I start running this, now sending telemetry. So I'm building up a JSON document. of the light value. So again, we're saying about the contract between the device developer and the cloud developer. My contract here is I send JSON with a value called light with the light level. And this is just read from the light sensor. This is that value between 0 and 1023, the 10-bit value we talked about last time. And I publish this to Mqtt. So this is now published to this ID / telemetry. And so if you were to be listening on this ID, you'll better see these values come through. That's it. That's my data being published. I can now think about picking up the data from the other side. So kind of the next thing is when I can think about retrieving that on the other side. And so I need to subscribe to that same topic to pull back that data. So normally you'd run this in the cloud. I'm just going to spin something up locally to do this. So what I'm going to do here, I'm going to just on my Mac, create a folder for this. And then let's create a virtual environment. I need to install some Python packages. So just create a virtual environment. And then you know what, let's open this in VS Code. It's just loading up. And this should, yeah. So that's activated. This is now activated my virtual environment. The Pylance extension in VS Code picks up. I've got the virtual environment, activates it. So what I need to do, set up my server, is also need to install Paho Mqtt. It's the same Mqtt library as before. I install that on my server. That's now installed. And then let's grab the code for my server. Essentially similar kind of things we had before. I need my ID. Let's just copy that over here. Here's my ID. I've got my same telemetry topic, ID plus / telemetry. And this time my client name is the ID plus nightlight server. I connect to test.mosquito.org. I start my client loop. But what I've got is I actually run the subscribe command here. So I call Mqtt client /subscribe, and I give it the topic I'm interested in, which is my telemetry topic. And then I've then set up this on message to handle telemetry. So every time a message is received from the Mqtt client, it calls handle telemetry. And this just prints this out. And now I've just got an infinite loop that sits there just polling. So I can sit there and just listen to process the messages. So if I take this and run py3app.py, there you go. So it's now receiving light 631. It's now receiving messages. So these messages are going from the Raspberry Pi up to test.mosquito.org. Then I'm subscribing that topic down here. So if I cover up, finger there to cover the lights, you'll see my message received light 216227. So we're getting the lower levels. Take my hand away. That number, like the number goes back up. So this date, the telemetry is going up and down to my device, down to my server. Now, what this leads to one question, which is kind of a good discussion point, is how often should telemetry be sent? And this is kind of a really important question when you think about building an IT application. How often, how much telemetry should you send? Siwa asked, those numbers are light sensitivity. These numbers are light measurement. We covered this in the sensor session last week. But essentially, I've got a light sensor here. It's an analog sensor, and it just reads values from 0 to 1023. So it sends an analog signal to the device, which gets converted by a digital to analog converter to a 10-bit number between 0 to 1023. So it's the measure of how much light is being detected. The higher the number, the more light is being detected. So how often should I send this telemetry? And the answer really is it depends. It all depends on what you need to do with the data. If I'm measuring the temperature in my house, I probably don't want to send data every second. The temperature doesn't change that often. I don't need to respond that quickly. Maybe every few minutes, maybe every minute, but it doesn't need to be every second or thousands of times a second. That's just a waste of data. If I send it once a day, that is not good because it's warmer in the day, cooler at night. So you need to get the right kind of amount of data. There is kind of this argument of it's better safe than sorry. So keep sending it all the data because we might use it one day. But the problem is you end up storing a lot of data. We talked back in the first episode, there's like how many zettabytes of IoT data. Most of that is unusable garbage. So if you're going to be capturing all this data, you have to think about how am I going to use this data? You also think about speed. How quickly are you going to get this data to the cloud? If you've got mission critical stuff and you need the data on a regular basis, then yes, you want to capture it more frequently, but maybe you want to process that locally. So like an edge device that listens for the data and does something with that data. So you want to monitor, say, for machinery for breaking down, you probably want to have an edge device that monitors for anomalies locally because that can handle the data faster. More data you get, the more you can do with it. You can train AI models, make decisions, but then you have to store it and manage it. You also need to think about internet speed, internet bandwidth. If somebody's got constrained internet bandwidth, you don't want to use up their entire bandwidth sending temperature data every thousandth of a second for a thermostat. It's just not useful. So a lot of things to consider. So again, this is where I've said before, a data scientist is your best friend. You need to work out what data is useful for a data scientist to do the analytics, what data you should gather. And then think about from a user experience point of view of the person using your device, how often should we monitor it? Do I need my lights to come on the instant that it gets dark? Or do I need to just give it's a few seconds okay? So there's a lot of topics to consider. You need to think about kind of the different use cases for it, and so work with a data scientist. Also, going back to Siva's question earlier, you need to think about loss of connectivity. If I don't have connection, what happens? If you look at IT for Beginners at this lesson, we link to a great post by the Internet of, I'm not going to finish off that name, bit of a swear word in there, but there's a Twitter account that points out some of the bad internet things, including a Ferrari that got bricked because it lost connectivity during an update. So C was asking about what happens if a drop connectivity in the middle of an update. This was a Ferrari that during an update lost connectivity because it was parked in an underground parking garage and it bricked the entire car. $150,000 car bricked because it lost connectivity. So you think about that connectivity. What happens? Do I need to store all my data and then when I reconnect, send it all? Or do I not care? If it's just my temperature, I can only make decisions on the latest temperature. I don't care about the data from an hour ago, so maybe I don't send it. If it's data used for training an AI model, store it and send it. But this is kind of the Mqtt doesn't do this for you. IoT services don't necessarily do this for you. You have to build up this logic yourself. If I'm not connected, I will store it and then send when I am connected. So something you need to keep in mind is how you manage that connectivity. Okay, so talked about telemetry, which is data coming from the IoT device going to the cloud. Usually when you send data back to an IoT device, it's in the form of a command, which is an instruction to do something. You are telling the IoT device, turn on the heating, turn on the cooling, reboot yourself, update your firmware, turn on the lights, whatever. It's an actual request to do something. So telemetry will come from like a sensor, and then a command would be a request to an actuator to do something. And so we do this over Mqtt. It's essentially treated as like a message. It's just what you do with the message. Telemetry is a message that you would receive and process the data. A command is a message telling you to do something. And that's what we can start adding now is commands to control our device. So let me just close all these down. Oh, didn't want to close that one down. Where are we? So when we get there, this is the Ferrari got bricked. Very funny story initially. The poor person who owned the Ferrari and had to get someone flown out from Ferrari to fix it for them. Right, so let's just grab some code here. I'm going to our server. So we've got our telemetry topic that we're listening on. We've also got our command topic that we're publishing to. So it's a different named topic. And then what we can do is in our handle telemetry function here, what we're doing is we're building a JSON blob. And we say this again is our contract between device and the IoT service is we send an LED on with a Boolean value. And if the light is less than 300, we send true. If it's more than 300, we send false. So if the light level is too low, we send LED on true, turn the lights on. Otherwise, we send false. And so if I just run this, so now start publishing a command. So you see, light is 632, we send LED on false. In fact, if I then cover up the light, LED on true. So we're now sending, every time we receive a light level, we send a message back saying whether the light should be on true or false. And that then goes to a command. Now we're just sending this just to the commands. This is not going to a specific device. This will be picked up by multiple devices. Well, the way to handle it for a specific device is inside the message that you receive on the client, you would use encode a device ID. And so we could put in here device 1, device 2, device 3, and then we send the command to /command/device 1 or /command/device 2. So we'll just send it on a topic for that particular device. You'll notice I haven't written any code to create the topic. They get created automatically when you send data to them. So when a new device is connected, it can automatically create a new topic to write commands to. So now, once I've got that, just go into code here. I'm going to add my command topic in here. So I've got my telemetry topic. I might now add my command topic. So we're listening on that same topic. And then once I'm connected to Mqtt, same as we had in our server here, we subscribe to a topic and set the on message function that gets called. We subscribe to the command topic, set our handler, and in our handler, we check the LED on and turn it on or off. And so if I then just restart this, you'll see we start with picking up. In fact, you know what? Let's just put these two side by side. So you kind of see we send 632, receive 632, send false, receive false. If I now cover up the light, you'll see we send 174, receive 174, and we send a message back, light on, true. And if I zip to my camera, you'll see the light is now on. Let's take my finger away, uncover it, give it a couple of seconds, the light goes off. And so when we send telemetry here, send telemetry 634, message received 634, send LED on false, message received false. And so this is zipping up and down over the internet. This is my device code here that runs on my IoT device. This is my IoT application that would run in the cloud. So there we go. We have got this connected over Mqtt. We've got it sending to the different commands. Again, loss of connectivity. You've got to think about how you handle loss of connectivity. Yeah, if I send a command, if I'm not connected, do I care? If this command is do something now, maybe I don't care because I can't do something now. If this command is update your firmware, maybe when I reconnect, I want to get that command. And so it's something to think about. More advanced services like Azure Iot Hub can do a whole things around commands. They can tell you when a command has not been received. They can actually queue up the commands. When you connect, you get them. It's so there's more advanced things you can do. But Mqtt is designed to illustrate the basic principles that we're doing here. So a little bit of homework for you, as this is the last in the 4 series. A little bit of homework is think about some of the IoT devices we talked about in the past. Think about the messages they might send and receive. And think about kind of the telemetry. Is it secure? Does the telemetry need to be secure? Usually, yes. What's being sent, what's being received? So just kind of have a thinking about some of these devices that we've talked about and how you can use these, and how these send and receive data. It's a good exercise if you're thinking about your own IoT devices. It's kind of think about, what data might be sent, what data might be received, how often it might send it, and then how you could then maybe apply that to your IoT projects. So this is the end of the 4 lessons that I'm running live. If you are following along, head to aka.ms/IoT-beginners, and you can carry on working through the rest of this series. And we kick off into farming, where we do digital agriculture, kind of on from there. Now, IoT, the T is things, it's hardware. You don't need hardware to work through IoT for beginners. We do support virtual IoT hardware. So everything that I do on the Raspberry Pi here, you can do with virtual hardware. It's like a little website that gives you an LED that goes on or off and a light sensor you can control. So you can work the whole of IT for Beginners without buying any hardware. But with that, thank you very much. AKAdem/IT-Beginners is where you go. Thank you very much for joining me. As I said, all over the internet at Jim Bob Bennett. Feel free to reach out and connect. Happy to answer questions. Jerry, Warzone, please reach out. Happy to talk and direct you some more of our beginner type content. But I thank you for joining. Kamal, thank you very much. I am very much looking forward to my vacation. Very excited for that. Janiscu says good show. Thank you. Shoulda Tech says thanks. Yep. Satya says thanks Jim for the fun session. Gabriel, yep. Smiley faces. Thank you. Oh, Ravi says virtual hardware. Yes, so we support, there's a project called Counterfeit that I wrote literally for IoT for Beginners. And this project allows you to simulate IoT devices. So you can actually spin up a website and say, I want an LED and a light sensor, and then you write the same code you write for the Raspberry Pi pretty much, apart from a couple of lines to say connect to Counterfeit. So check out IoT for Beginners, all the details there. It supports all the hardware we use in IoT for Beginners. If you want to help add more, please raise pull requests to add more hardware. It's kind of a great tool, so you don't need to buy anything. But yeah, Babita, thank you very much. Yes, I'm really looking forward to my vacation. It's very, thank you very much. Cool. But honestly, thank you for joining. There was a link being put in the chat for a survey with event ID 16485. Please give me your feedback. If you want me to run the entire series, if you think that has value, let me know. If you're interested in folks running through some more beginner content, let us know. We want to tailor these live streams to what you want and what you need. So please fill out our surveys. That allows us to make sure we're serving up the right content that you want. But thank you very much, everyone, and enjoy the rest of your day.